All right, so before we start this, I just want to kind of recap what we've been doing. Um, Essentially, first of all, let me point out a couple of things. This QR code, if you scan that with your phone, don't get your phones out right now. Don't don't do it. Put it away. I don't want you. But if you take this worksheet packet home and you need a resource, you can scan that QR code. It gives you some information. Sometimes it gives you a calculator. It'll give you access to the video. You can use it if you want to. Basically, this video that I'm recording and all the other stuff is going to be posted in Schoology. But I just want to explain what that is. But anyways, like I was saying, what we've been doing so far in class is we've been using algebra to solve things. And so basically, whenever we use algebra to solve some things, and I want you to write this down at the top here, it says, how do you rewrite formulas and literal equations? Well, this is an easy answer to this, okay? Essentially, what you do is you, you make stuff look like x equals some stuff, and I'll explain what that means as we do these problems. And the way that you do that is you do the inverse, and sometimes you guys will say opposite. I used to have friends that were math teachers, and they would teach the kids opposites, right? I don't like to say opposite. I like to say inverse because technically that's what you're doing. You do the inverse. And so before we jump into that, let's list what inverses are. And then we'll do some work, okay? So, what's the inverse of adding? Subtracting. What's the inverse of multiplying? Division. And vice versa, right? The inverse of division is multiplying. The inverse of subtraction is adding. So whenever we want to solve or isolate a variable, which are some technical terms that Mr. Adams will use, we do the inverse to make it look like the variable that we're solving for is on one side of the equal sign and all the other stuff is on the other side of the equal sign, okay? So let's look at A. So, well, let me read this to you. It says literal equations, and I'm just reading this stuff here, okay? Literal equations that contain, literal equations are equations that contain two or more variables. There are many literal equations in the form of math, science, engineering formulas. These formulas may seem like they can only be solved for the variable that is isolated on one side of the formula. By using inverse operations and properties of equality, a formula can be rearranged so that any variable in the formula can be isolated. There is no difference than how the equations are solved by using inverse operation and the properties of equality. Now, right next to where it says property of equality, you're going to say blank of equality. So if I add, you would say the addition property of equality. If I subtract, I would say the subtraction property of equality. But Mr. Adams, to make it easier, I'm going to use the phrase whatever. You guys should be writing this down. Whatever, that's the word whatever. Whatever I do on one side of the equal sign I do on the, I've probably said it to you guys in class before. Help me finish that sentence. Whatever I do on one side of the equal sign, I do on the other side. So to solve an equation, whether literal or otherwise, Whatever we do on one side, we have to do to the other side. Now, that's a property of equality. If I add on one side of the equal sign, then I have to add the same thing on the other. If I subtract on one side, I have to subtract on the other. If I multiply, I have to multiply on the other. If I divide on one side, I have to do. Now, when I do that, it makes both sides equal. Okay? So let's look at this. So I want to unpack this. Remember, this we're asked to solve 42 equals 6x. Now, you could guess what number x is. Remember that x is a variable and it represents a number, and you could guess what it is. Or you could use algebra. When we want to use algebra, what I want to do is I want to get the x all by itself. When I say 6x, what I'm really saying is 6 times x. What's the inverse of multiplication? Huh? Yes. So we would divide by 6. And whatever we do on one side of the equal sign, we have to do on the other. Okay? Now, what does this look like? What does this look like in terms of algebraic concepts? What do I write down on our papers? Okay? So the first question is, what is the reasoning for dividing? What do you guys think it is? Say it out loud. What did Mr. Adams say? Well, we want to get x alone, but why are we choosing to divide? I said it. 6x means 6 times x, and division is the inverse of multiplying. So what that means is when I look at the x and I want to get the x by itself, I go, what is the number doing to the x? In other words, I want to move this 6 away from the x. What is the 6 doing to the x in this first line? It's multiplying. What's the inverse of multiplication? 6. So why divide by 6? It's the same thing. To undo by 6. So if I say 6x is 6 times x, to undo what's being done to the x, in other words, to get rid of this 6, I need to do the opposite or inverse of multiplying by 6, which is to divide by 6. Now, what is 6 divided by 6? 1. What's 1 times x? So 6 divided by 6 reduces down to 1. Okay, what's 42 divided by 6? 7. So 7 equals 1x, or 7 equals x. Does that make sense? Remember that a fraction, the numerator over the denominator is the same as the numerator divided by the denominator. So in algebra, it's just convenient to kind of write it like a fraction, but we're really dividing. Okay? All right, so now that you guys are experts in this, let's try to finish this page. So the mathematical formula for the volume of a rectangular prism is the base is equal to the volume times the height. Or the volume is equal to the length times the width times the height. Okay. This is a literal equation. So then the volume represents, or capital V represents the volume, L represents the length, W represents the width, and H represents the height. Using inverse operations of the formula can be rearranged to solve for any one of these variables that might be unknown. Like solving for x, the formula can be rearranged to isolate a variable. We want to isolate the h. So it says in the formula, volume equals the length times the width times the height. The variable h needs to be isolated. That means I want to make it look like h equals some stuff. Okay? So I have LWH. What does LWH mean? Well, L represents a number, W represents a number, and H represents a number. But mathematically, what are we doing with those numbers? What is L doing with W, and what is W doing with H? When we write two variables together like that, we're really implying that we multiply them. So the operation of multiplication is used in the formula. Okay? We're multiplying those numbers. The inverse operation, what's the inverse of multiplication? Division. Should be used to isolate what? What are we trying to isolate? Well, it told us to isolate H, right? So that means I need to move the L and the W, which we know means that we're multiplying L and W times H. So to move L and W, what do I need to do? Divide by L and W. So over here, I'm going to put L and I'm going to put W. I could do it all at once. Now, whatever I do on one side, I have to do to the other. Now, this doesn't say it in your textbook. I'm going to write this down. When I divide both sides by the same value, that is the division, because I divided, division property of equality. So when you, and this is an important thing to learn of equality, well, let me draw that a little better so it's easier for you guys to read. I promise you, there is going to be a question on the NWEA or the SAT somewhere on some standardized test where they're going to say, tell me the property of equality used to solve this equation. So there's three things. One, we need to get H by itself. Two, we need to move the L and the W away from the H. Three, the L and W are being multiplied by the H. So to move them, I do the inverse, which is division. Four things so far. I've divided by L and W. Whatever I do on one side, I have to do to the other because that's the division property of equality. Now, what is L? This is going to be a little tricky, but I think you guys are smart enough to figure it out. What is L divided by L? Anything divided by itself reduces down to 1, so that's 1 over 1. What is W divided by W? 1 over 1. What's 1 times 1 times H? H. What's H over 1? Because we've got 1's on the bottom, just H. And then we're left with V over LW. So in other words, H equals the volume V divided by the length times the width. Okay? Now, lastly, before we end this video, it says use the formula for a rectangular prism to rewrite the formula for L. So the formula was V equals L times W times H. We want to solve for L. What do I need to move away? W and H. What does the W and H do into the L? So what is the inverse of multiplying? Divide. What am I dividing by? W and H, right? Because I want to solve for L, so we leave the L alone. Whatever I do on one side, I do to the other. Does anybody know what that property is? It's the, what kind of property of equality? It's the division property of equality, because we divided both sides. Division property of equality. Does that make sense? Okay. I'm going to stop the video. I'll leave this up for a second so you guys